All right, let's talk about a problem that I know hits close to home for so many of us who are trying to really push the limits of AI on our own machines. We're talking about the hidden bottlenecks, the things that are secretly, silently just killing your performance. So, you've got the vision, right? You are ready to run the latest, greatest large language models, maybe some incredible diffusion models, and you're going to do it all on your own machine, locally. No cloud, all the power is right there with you. You've gone out, you've invested in a beast of a GPU. Maybe it's an external GPU to supercharge your laptop or a mini PC. But then you hit that first critical decision point. How in the world do you connect this thing to squeeze out every single drop of performance you paid for? And let me tell you, this question alone sparks some of the most intense debates you'll find online. In one corner, you've got Oculink. This is the enthusiast choice. It promises raw, pure, unadulterated speed because it's a direct connection to your system's PCIe lanes. And in the other corner, you have the champ of convenience, Thunderbolt or USB 4. It's everywhere, it's flexible, and the forums are just full of people going to war over which one is truly king. Okay, so let's dive right into this hardware showdown. The community has some really strong opinions here, and honestly, for very good reason. I mean, just look at this quote from Reddit user anti22. They say if your one and only goal is pure GPU performance, then Oculink is the clear winner. It's built for speed, and that's it. But, is it really that simple?
Let's break down the specs. Oculink gives you that direct PCIe 4.0 connection, which means up to a whopping 64 gigabits per second. And crucially, lower latency because there's no extra protocol getting in the way. But then you have Thunderbolt. Sure, Thunderbolt 4 is a bit slower on paper, but it has these huge quality of life wins, like hot plugging. You can connect and disconnect without a full reboot. Plus, it's basically everywhere. Oculink, it's a super niche port you're only going to find on very specific mini PCs or handhelds.
So what does all this tech spec talk actually mean for running AI models? Well, what the community has found through a ton of testing is that for running inference on a single GPU, the connection speed, it barely makes a difference to performance once the model is loaded. Now, if you're getting into these crazy multi-GPU setups, yeah, the bandwidth really starts to matter. But for most of us, the real annoyance, the true pain point of a slower connection like Thunderbolt is how long it takes to load the model in the first place. Switching between different models becomes this agonizing waiting game. So that's it, right? Just pick Oculink if you can find one, and if not, just learn to live with slower loading times on Thunderbolt. Case closed. Well, not even close. See, we've been so focused on the cable, we've been arguing about gigabits per second and latency, that we've completely missed the bigger picture. What if obsessing over that GPU connection is just a total distraction from the thing that's actually killing your performance? Because here's the hard truth. You can have the fastest GPU on the planet, connected by the most powerful cable imaginable, but if you can't feed it data fast enough, it just sits there. It becomes a very expensive, very idle piece of silicon. It's literally being starved. And this chart, this just puts the whole problem into such stark perspective. Look at the top. A powerful piece of hardware, like a TPU V3, can absolutely chew through over 1 million samples per second. That's its potential. But then, look at that dashed line way down at the bottom. That's what often happens in reality. A typical, unoptimized data pipeline might only be able to feed it a few hundred. The gap between what your hardware can do and what it's actually doing, it's just enormous. I love this analogy. Think about it this way. Your GPU is a world-class chef. This chef can cook an entire gourmet meal in 60 seconds flat. Amazing. But the data pipeline, that's the kitchen prep team. And if it takes that team 10 minutes just to chop the vegetables and bring them over, who cares how fast the chef is? The entire kitchen grinds to a halt, waiting for ingredients. So let's talk about the prep team. Let's dig into this data pipeline problem, because this is where the real massive speed gains are hiding in plain sight. So what exactly is this data pipeline we keep talking about? Well, it's the entire sequence of steps, the whole assembly line that your computer has to run through to get raw data, like an image or some text, ready for the AI model. It's not just about opening a file, it's a whole series of transformations. And this problem, it has just gotten exponentially harder over the years. I mean, look at this chart. Back in the day, a data set was a few megabytes. Now we're dealing with data sets that are tens of terabytes. Trying to move and process that much data is a monumental task. And it's very often the real reason your training feels like it's stuck in mud. Let's make this super concrete with a simple image pipeline. First, you've got to read maybe thousands of image files from your drive. Okay, step 1. Then, for each one, you have to decode it from a compressed format, like a JPG, into a raw matrix of pixels. Next, you have to resize that image to the exact dimensions your model is expecting. And finally, you might do some data augmentation, like a random crop, to help the model learn better. Every single one of those steps takes time and precious CPU cycles. So there are two classic ways people try to handle this. The first is the all-online approach. You do every single one of those steps on the fly right during training. This is really flexible, but it can be painfully slow because your CPU is just burning itself out trying to prep data while your expensive GPU is just sitting there waiting. The other extreme is all offline. You do all the pre-processing once, way ahead of time, and save the results. That sounds way smarter, doesn't it? Just get all the slow work done first. But there is a huge hidden cost. And that cost is storage, a massive amount of it. That 146 gigabyte data set of JPGs, once you decode and save everything, it can explode to over 1.5 terabytes. You've just traded a CPU bottleneck for a colossal I/O bottleneck. Now, instead of slow processing, you're stuck just trying to read this gigantic data set off your drive. And this right here, this is the aha moment. This chart just lays it all out. Neither extreme is the best answer. The all-online strategy, you can see it's slow. The all-offline strategy, it's a little better, but it's not great. But the optimal strategy, it's a hybrid. It's about doing some steps offline and some online. And this balanced approach, it can give you a staggering 3x to 13x increase in throughput. You're finally feeding the GPU at the speed it was built for.
So, how do we find this magical sweet spot? Let's bring it all together and figure out how we can actually apply this stuff.
It really all boils down to this one idea. Are you focused on micro optimizations or macro optimizations? You can spend all day agonizing over tiny details like which cable to buy, or you can step back and fix the big picture problems that will give you a massive order of magnitude improvement. So what's the big takeaway here? That whole debate we started with, Oculing versus Thunderbolt? It's a micro optimization. It's not that it doesn't matter at all, but it's not the biggest fish to fry. The true bottleneck, that macro-level problem, is almost always your data pipeline. And remember, going all in on offline preprocessing is a trap. It can backfire and create a storage nightmare. The real secret, the goal, is finding that perfect balanced split between online and offline steps for your specific setup to feed that GPU at maximum speed. So the next time your AI training is just crawling along and you're tempted to blame your hardware or you start browsing online for a faster cable, just ask yourself this. Are you still trying to make the chef faster, or are you finally ready to go fix the prep kitchen? Because finding your real bottleneck, that's the key to everything.